And here to provide an overview of the report is Dr. Chuck Rice, who is a University Distinguished Professor of Soil Microbiology at Kansas State University. He was also a lead author for the AFLU chapter of the IPCC Fifth Assessment Report. He is also a co-lead of the Component 1 on measurement for the Cropland Research Group of the GRA, the Global Research Alliance. He's on the board of CIAT, and from my perspective and the organization I work with, CCAFS, he is also on our International Science Advisory Panel. So, Chuck, please.
Thanks, Lenny. And thanks for printing off the bound document. I didn't even see that. I just had an unbound copy in my file, so that was great to have that available. So what I'm going to do is just give an overview of the Chapter 11, AFLU, and I'm going to focus on ag because that's what this meeting was about. So I'll mention forestry, but not too much. So, and this just got approved Sunday in Berlin. So this is some updated slides set. So just to put it in the context, Jorgen mentioned about the emissions. This is the current emissions. I don't like this, so I can't see. But you can see here, and I'm sorry for, I know the taping, but it's not going to show up there. The CO2 emissions for AFLU are shown here in the darker red. That's been going up, but most of the increase is due to the energy sector. N2O and methane are a bulk of those come from the agriculture sector. But if we look particularly at the AFLU component, this is over the last 4 decades. It's gone up until the last decade, and then it's declined. Most of the decline has been due to decreased deforestation. So not so much from the ag sector, but from the forestry sector, and that decline there in the reduced emissions and changing of land use in that sector. But I'll talk about some of the other components of the ag sector, I think, in the next slide. So here's the key emissions for up to 2005, different studies that show that. And if we break those down, and I'll show some more information on the mitigation aspects, but if you look at the major emissions, they come from agriculture soils, mostly N2O in that case, and some methane. Enteric fermentation are the bulk of the emissions as recorded in 2005, and then manure management systems and rice cultivation are also shown there. So the total represents about 5 gigatons of CO2 equivalent per year, which represents about 10 to 12% of the total anthropogenic emissions. Total, and Jorgen mentioned that the total is around 25%, so about half of that is from agriculture, the rest would be from forestry and other land use. So that's the emissions footprint. I think from the World Bank standpoint and also CCAF's standpoint, we need to look at it, instead of aggregated or globally, we need to look at by region. And so that's what this is trying to show, is that for soils component, sorry, it's the angle here, Asia and OECD countries are the major source for emissions in that sector. Enteric fermentation, pretty much evenly across the board, although a little bit higher for Asia and Latin America. Manure management, pretty much even, and obviously for rice cultivation, Asia stands out there as you would expect as the major sources of emission. And the reason I put this up here is from a mitigation and understanding where those emissions come from, where we need to target certain activities. So that just gives you an idea of the emissions factors for that. If we look at generally the mitigation activities, which is what our chapter was responsible for, They can categorize in several areas here: reductions in methane and nitrous oxide emissions. Nitrous oxide represents around 80–85% of the N2O emissions globally for anthropogenic. Methane in the agriculture sector represents about 50% of those total emissions in the methane category. But we can reduce those in cropland, grazing lands, and livestock. And I'll go into some detail, and Harry will talk a little bit more detail, particularly livestock, later on. We need to look at conservation of existing carbon stocks. This primarily results or is intended for forestry, but also in high carbon soils like peatlands, wetlands that would have high carbon stocks. And so it's avoided carbon loss in that sense. But again, mostly for the forestry sector, not for the ag sector. Another broad category, the reductions in carbon losses through management changes. Again, this is primarily in the ag sector. And I'll detail some of those by looking at carbon management of soils in particular, and then reducing the losses of carbon in carbon-rich ecosystems, again, peatlands and that. Enhancement of carbon sequestration in soils. I think that'll be a major topic today in biota and long-lived products, primarily forestry. Also changing the land, the albedo of the land use, land cover that would reflect visible light, and then finally provision of products with low greenhouse gas emissions that can replace products with higher greenhouse gas emissions. And again, this is primarily looking at wood products replacing cement, which is a major producer of CO2. So those are the broad categories. What I specifically want to talk about then is in agriculture and what we can do in agriculture to reduce and retain those, reduce the emissions or sequester carbon in soils in agriculture systems. So I've got a kind of pictorial diagram here, and I'm going to give some of the details in the report that I couldn't show in the slide set. But basically in cropland, we're looking at conservation ag, and I'll talk a little bit more about that through reduced tillage, no-till or zero-till, whatever you want to call it, being a prime example, intensifying the rotations and diversifying the rotations. So I often talk about, instead of intensification, I talk about intensification and diversification. Cover crops in locations where that's viable, fertility management, mostly in the sense of nitrogen management in this case. Because N2O is a major emission source, we need to do a better job of managing the nitrogen fertilizer. When I was just at a workshop in Paris last month where we focused on that for the GRA. Erosion control, keeping that soil and carbon on the landscape. Water management, because irrigation particularly is an energy-intensive process. We need to figure out how we can be more efficient with water, and then because of that, less energy use in that system. Grasslands, I need to mention this because it's particularly important for Kansas, but where I'm from, but also around the world, grazing lands are a major opportunity for mitigating, either through proper grazing activities, fire management in some cases, and fertilization in some of those managed grasslands. Rice paddies, again, we're looking at water management because methane is a major emission source. How can we manage the water to reduce those methane emissions? Fertilizer management for N2O, and then residue management, again, mostly from a carbon cycling standpoint in soils. And then there's some other land uses, agroforestry, integrated systems. It was mentioned about the systems approach. We need to be thinking about that in multiple activities on a single piece of land, and I got a picture example of that. One thing I don't have a picture of, I didn't get, was the restoration of degraded lands, particularly high organic matter soils. That's a major mitigation opportunity, is restoration there and water management of those systems. So just an example of a system, and one that I guess I personally work on, but to show this approach is conservation agriculture. The nice thing about it is it does, in many cases, not all, it restores carbon in soil, so it's a carbon sequestration process. But from an adaptation, a climate-smart agriculture resilient standpoint, it conserves moisture, so it provides a key component in adaptation to changing climate, and particularly those sensitive areas there on the margins, and Kansas is one of those, is that moisture is really critical, and so it provides an adaptation as well. At least in mechanized agriculture, it saves fuel. That was one of the reasons that conservation ag no-till was adopted in the U.S. and Brazil and Argentina, because of the fuel savings and the time labor savings. And so the fuel savings is important because then that reduces the emissions from agriculture as well. And then there's a lot of ancillary benefits. It improves habitat, wildlife habitat. You get a little more flexibility in planting date, and so there's some other aspects as well. And important from a food security standpoint, improves the soil health, and so that makes that system more productive. So some areas of concern since the AR4 was published is that food security has risen to a more prominence issue, and so if we're going to reduce hunger, and it was mentioned in the talk from the World Bank, is that, and with population growth, that we're going to have to increase food production. So the question is, can we increase food production intensify that in a sustainable way? And that's going to greatly affect how those emissions occur. So we need to be thinking on the fringes of the box or out of the box to develop agriculture systems that can increase the food production as well as lowering that greenhouse gas footprint for our sector. But I think that can be done. We do have to be careful that we don't, forestry is a sector that has a large potential for carbon sequestration, but we can't do trade-offs and take land out of production necessarily. And the same thing with the bioenergy sector. That was one of the major discussion points, is we have to be careful that we don't have competition for land use. Another factor that we had some good discussion in the chapter was looking at greenhouse gas emissions intensities. And this is particularly important. If we're going to increase food, we have to increase food production, but then we have to reduce or increase the efficiency or reduce the intensity. And that's what this is showing. I think Harry's going to talk a little bit more about this later. But basically, this is showing the last 50 years or so emissions intensity for different components. And we're doing a better job. We could do better. Was that me? Okay. All right. No, that's all right. But we need to do a better job, but there are opportunities there to improve the efficiency, and we need to do that if we're going to increase food production, yet decrease our footprint. Some other factors on the demand side that we also showed in the report was we need to reduce our losses in the food supply chain. Somewhere estimates are 30 to 40% of our food produced is lost from harvest through consumption, and that varies in different parts of the world, depending if it's before it gets to the table or after the table. In the U.S., from a food safety standpoint, we tend to waste a lot after we leave it on the table. Other places, it's more the storage factor. Another highly debatable factor is changing in human diets to less intense emissions. And then there's some also demand side options for wood and forestry. let's see. Okay, so how are we doing on time? Okay, all right, good. So if we look at different mitigation options within the ag sector, several things that show up here, and it depends on the price of carbon, the demand for some of these mitigation measures. But the top 3 or 4 are essentially cropland management, and that's basically, for the most part, this is by 2030, by the way, is through carbon sequestration, primarily in a little bit of N2O management, or nitrogen management for nitrous oxide, restoration of cultivated organic soils, grazing land management, again, mostly from a carbon sequestration standpoint, and then restore also degraded lands. And again, that's mostly from a carbon standpoint. And then some other options in the next 20 years or so would be rice management and livestock emissions would be the greatest opportunity within that. And conservation ag, some of the things I mentioned earlier would fall in some of these categories. If you look at it by region, and again, I put this up here to show where we can target, or where we should target, at least from a World Bank standpoint and from CCAFs, is you can see the different activities. The top bar would be forestry, but everything underneath that would be more of the agriculture related. And again, it depends on where you are. Restoration of degraded lands and organic soils show up primarily in the OECD countries and Asia. And then rice management, again, in Asia, as you might expect, and cropland management, again, mostly in Asia, but really across board, OECD as well. So those are the major regions where you can expect it by 2030. Okay, so that's the economic potential. Okay, so there's technical potential and the economic potential. Now, what are the barriers? Okay, there's socioeconomic barriers and opportunities. We need to look at coverage of financing mechanisms, and I think that's going to be talked about later. It's the scale, whether you go to local, regional, or national scales. You have to worry about poverty. That would be barriers. Institutional capacity. Do we have the outreach, extension, education services to help farmers adapt some of these technologies? There's ecological barriers with climate change that might help or hurt mitigation opportunities. And then there's technical barriers, and one I know I've been at the World Bank before is measure, monitoring, and verification, and that's always seems to come up on that. Sectoral policies. There's economic incentives. We can look at emissions trading, anywhere from voluntary to regional or mandatory. Taxes and charges, subsidies, and then there's a regulatory approach as well. Okay, so couple last slides. Frequently asked questions from the chapter. One, I think it's important that agriculture represents about 10 to 12% of the global greenhouse gas emissions. From, let's see, other land use, again, that represents about 11%. What's the potential for mitigation? The economic mitigation potential, there's a wide range there, from 0.5 to 10.6 because of the uncertainty in that. But it has a significant role. Depends on what range you want to use, but agriculture can basically offset about 60% of its emissions up to 100% of its emissions if everything worked perfectly. Obviously, you know that doesn't, but within our sector, the agriculture sector, it can basically major role. Food waste can also is a key role. Changing in diet has a large potential, and then forestry as well. So in summary, one thing is unique about agriculture and AFLU is that we can enhance removals as well as reduce our own emissions. That's different than the other sectors. And again, we represent 25%. There's opportunities both on the supply and demand side, but there are barriers, and we need to realize those, and that will probably be some of the discussion later on. And then the economic potential is somewhere around 7 to 10 gigatons, depending on the carbon price, and about a third of that can be achieved at a low carbon price of $20 a ton of carbon. And then finally, again, further discussion that policies are needed will govern how much we can look at for mitigation and adaptation. I think that's my last slide. So thank you.